All right, let's just dive right into this. Welcome to today's Explainer, where we're going to untangle something that surrounds you every single day, even if you can't actually see it. We're talking about the Internet of Things, or IoT. But look, we are going to skip the dry corporate jargon today. Instead, we're going on a bit of a journey to uncover the hidden mechanics of this invisible web that completely powers our modern world. If you've ever wondered how the physical world and the digital world manage to seamlessly blend together, well, you're in exactly the right place.
Think about this for a second. How does a smart house actually know you're home? You walk through the front door and, almost like magic, the hallway lights fade up, the thermostat adjusts to your preferred 72 degrees, and maybe your favorite playlist starts playing softly in the background. It feels like magic, right? But it's not. It's actually a highly orchestrated split-second conversation between dozens of hidden devices. The Internet of Things isn't some distant sci-fi concept anymore. It is literally all around you, silently anticipating your needs.
And a smart home environment is the perfect starting line for what we're going to call our data journey. This is where physical, tangible spaces are transformed into living, breathing digital ecosystems. Now, to bridge that gap between the physical and the digital, we rely on the absolute unsung heroes of IoT, sensors and actuators. You can think of sensors as the eyes and ears of the system. They're out there on the front lines collecting raw data, detecting motion, measuring the temperature, sensing the ambient light. Actuators, on the flip side, are the hands. They receive a digital command and perform a physical action, like physically flipping a light switch or opening a water valve. But here's the thing, those eyes, ears, and hands, they need a brain to make sense of everything. And that brings us to the cloud. This is where all that localized data eventually travels to do the heavy lifting. The cloud offers massive on-demand storage and processing power on a global scale. So from the little sensor in your hallway all the way up to cloud servers thousands of miles away, this is what makes up the basic invisible web we interact with daily. So here is our data journey. Sensor, to the network, up to the cloud, into analytics, and finally resulting in action. Section 1. The hardware brains. Circuit boards that make devices smart. Getting the right hardware for the job is absolutely crucial. Let's pit the two most famous boards against each other. On one side, you've got the Arduino. Think of this as the system's spinal cord reflex. It's a microcontroller that uses very low power, it's incredibly cheap, and it is perfect for real-time sensor reading and precise timing. It acts instantly. Then, on the other side, we have the Raspberry Pi. This is the actual brain. It's a full microprocessor running a Linux-based operating system. Sure, it consumes way more power, but it can handle heavy processing, machine learning, computer vision, the whole shebang. In a really well-designed IoT ecosystem, you actually use them together. The Arduino handles the quick reflexes, and the Pi does the deep thinking. Section 2. How smart devices talk. The network layer. Now you might be wondering, how do these low-power devices talk to each other without just instantly draining their batteries? Well, they can't use heavy, traditional internet protocols. They need something lightweight. First up is MQTT. This is a brilliant publish-subscribe messaging protocol. So instead of devices constantly shouting at each other all day, they use a central broker. It operates over TCP, and it is perfect for low-bandwidth telemetry. Then we have Zigbee. Built on the IEEE 802.154 standard, Zigbee lets devices create a low-power mesh network. Basically, this means your smart bulbs don't all need to connect directly to your main Wi-Fi router. They just quietly pass messages to each other, which saves a massive amount of energy. Section 3. The data pipeline, moving upward. These IoT devices are generating huge, frankly, mind-boggling volumes of data. And it all flows through a distinct 5-stage pipeline. It goes like this. First, collection at the sensor level. Next, storage to hold all that raw information. Then, processing to actually organize it, followed by analytics to extract some sort of meaning from it, and finally, decision-making to trigger an automated response. But where exactly is all that processing happening? Well, it really comes down to a dynamic between fog computing and cloud computing. Think of fog computing as your local branch manager. It pushes intelligence closer to the edge, right there near the physical devices. It handles immediate, time-critical tasks to reduce latency and save bandwidth. Only the summarized, meaningful data actually gets sent up to the cloud. The cloud, on the other hand, acts like the CEO. It handles massive data storage, complex global analytics, and long-term strategy. Section 4. Turning data into action, the climax of the journey. To actually find insight in all this data, we apply 4 types of analytics. First, descriptive. Basically, what happened. This is just summarizing historical sensor data. Second, Diagnostic. Why did it happen? This is where we find the root cause of an anomaly. Third, predictive. What will happen? This is forecasting future conditions based on past patterns. And finally, the holy grail, prescriptive. What should we do? This recommends or even automatically takes the optimal action without any human intervention at all. And the engine driving those predictive and prescriptive analytics, that's machine learning. Look, engineers can't explicitly program a system for every single conceivable scenario. It's literally impossible. Instead, machine learning allows the system to learn from historical data over time. By constantly analyzing endless streams of sensor readings, the system finds hidden patterns in the noise. It gets smarter and it makes increasingly accurate automated decisions entirely on its own. Section 5. The human element. When the system meets the user. So the system has made a decision, and now it has to interact with us. This introduces a really fascinating interdisciplinary field called human-robot interaction, or HRI. And this isn't just about engineering. HRI combines computer science, psychology, sociology, and design. Its entire goal is to figure out how people and robotic systems communicate, how they build mutual trust, and how they can safely and intuitively share the exact same physical spaces. The absolutely crucial point here is managing user expectations. I mean, what happens when an automated system or a robot does something you just didn't expect? Psychologists call this a mental model. It's the internal belief a user holds about how a system is supposed to work. If a hospital delivery robot suddenly reroutes itself without signaling, your mental model is mismatched. You're going to assume it's malfunctioning. And that causes confusion, it causes surprise, and most dangerously of all, it instantly erodes your trust in the whole system. This directly translates into the cognitive pipeline of the user. Every single thing a smart device does, whether it's a flashing LED, a little beep, a sudden movement, it has to pass through human perception and cognition before it means anything at all. You perceive the signal, you cognitively comprehend why it's happening, and then you decide your response. So the golden rule of IoT and robotics design is this. You have to design for the human in the loop, not just the robot on the floor. If the user doesn't understand the system, the technology fails. Period, no matter how advanced it is. So, we follow the data from a tiny physical sensor up through the network into the vast analytical cloud and right back down into a physical human interaction. It is a modern miracle, and it's happening millions of times a second. But I want to leave you with a provocative thought as we wrap up this explainer. As the Internet of Things rapidly expands into what we might call the Internet of Everything, the boundaries between our convenience, our data sharing, and full automation are blurring fast. The invisible web is only going to get tighter. So how much of your daily life are you truly willing to hand over to the algorithm? Think about it. Thanks for joining me on this explainer today, and I'll see you next time.